Hello everybody, welcome to another episode of Analytics Mindset. In this time around, we will go into the basics of natural language processing with Python. This is a little bit of a more advanced topic compared to other more basic programming concepts that we have seen before. However, I also wanted to do this because of the natural language processing boom, chatbots, etc. My recommendation, you should start understanding the basics of natural language processing before you start going to LLMs or any other kind of very advanced machine learning on text, etc. But that is just my recommendation. It never hurts to at least understand the basics of what's happening behind the scenes before you run into these very complex models and then you just run away and put an LLM anywhere where you want to. We will be using two packages here in this time around. The two packages are from NLTK actually, and one of them is the Tokenize, as you can see here. This is the first one, and you can see a very small description there. The other one is a sentiment analysis package that we will use later on. I will start by importing these packages. If you do not have NLTK, it is actually a very big package. You will need to run this. Yes, uncomment this, and you are ready to go after you run it. We will use a string, and going back to our previous lessons on data types, etc. A string is nothing more than text. Computers have a very hard time understanding text because they think zeros and ones. That's part of the reason why. There is a lot more to that, but the gist of it is computers have a very difficult time understanding text because it's just very difficult for them to break down the actual letters. And human language can be very complicated. Because of that, this is our example. Read it on your own time, but I created it for this. This is a string that will help us understanding natural language processing, and then I have three more sentences there to give it some kind of depth. But it is made up for this. You could put a whole book here. Actually, there is a lot of books out there that you can import on Python in the corpus. But for now, I'm just going to go ahead and run this. You can see how I create my first variable, string x, and it's nothing more than the text that I just inputted there. These triple quotes just means it's a multi-line string. Everything here is in the string, including this space and line break. If they ask you what is the most basic stuff you can do in Python with a string, obviously you can print it. You are just returning the same script, the same string here in the console. As you can see, I can hop over it and see the actual string here. Notice that it has the same structure as before, and it actually has the line breaks that I was intending to keep. We can also get the length of the string. You may see here the size of it, and if I actually run the len function, I get exactly the same. This is just the number of characters that you need to represent that string. Python treats strings as their own class. You can just go into type. You can see substring class, but you can also iterate through them. Going back to the iterations, you can actually see here, you have gone through every single letter in this string. Python has gone through every single letter and just iterated through it. Again, nothing very different than our previous lessons, but keep in mind, and I will put it somewhere here on the screen too. If you want to understand what Python is doing, it's just a type of list. You can think of a string as a very sophisticated list that stores human language value, and you can do a lot more with it. Now, again, computers cannot really understand text. We kind of need to make them do it. And for that, programming languages have extensions. Again, in Python's case, we're using NLTK. And one of the most basic tasks is this thing called tokenization. We can take string. There is PhDs there in tokenization and language processing, etc. I'm not going to go that in deep into it. Maybe I will make a little bit more into that, another kind of language analysis later on in linguistics. But for this video, tokenization just means taking the string and split it into its parts. In this case, we will focus on words and sentences. We are going to take that string and split the words and split the sentences and take each of those independent sentences and words separately. We have functions for that. We don't need to worry about doing that by ourselves. And we want to get the meaning of that string. We want to get the actual meaning behind it of the text. You can see here we have this function send tokenize. That is the function that we'll use for this. And we will just store it in a variable called send. This is going to take this string and split that string into different sentences. Then we can print those sentences here. Here you go. You have your first sentence until the comma, then another sentence until here, then another sentence, and then yet another sentence at the end. Notice that this is a list. You can print that list, get the length, or even get a specific value from it. And that's where a lot of other functions from the NLTK package take advantage of this to process these sentences. And why it's not required, but it helps a lot with very different kind of analysis that you would do in text later on. The most big stuff you can do is just printing. Again, it's just gonna send you the output from the console. Then we have the length of the string. You can see here how we get 4 sentences. You could make this output prettier if you wanted to, and I would encourage you, if you want to practice a little bit more outside of this video, to just put this as 4 sentences if you want to make the output prettier. You could also take the second value. Remember that Python starts with index 0, and they will be the second sentence of the string, and we can do the same for the third sentence if we want to do it with 2, for example. And that will just return us the index number 2, that is the third sentence here. Now we will do exactly the same that we did here for words. And if we print the words, you will notice that instead of having all the string together in sentences, we just did it in words. How is NLTK doing it? There is a whole theory behind it and how do you interpret the meaning. And usually for words, it's actually easier. It uses the spaces. Doesn't work in all scenarios, but it works in 90% of scenarios for English. On sentences, it's also a little bit more complicated because you have things like very long sentences. Periods are usually used. The dot at the end of the sentence is usually what marks the end of a sentence, but it really depends from time to time. You will need to be aware of that when you're working with this kind of data. You can use len to get how many words are there. And you can see there is 60 words. We can get the first word in the text using 0 because this is the first index. And as you can see, is this because all of this is just a list of words. Now, the next part is stop words. You might need to run this code for the first time that you're using it. And NLTK has a ton of optional downloads. If you get an error with NLTK, most likely would you just need to NLTK that download whichever module you're missing. For NLTK, we are going to also use stop words. Again, there is a lot of linguistic theory behind it, and you can go very deep onto why we use stop words, why we don't want to include them. But the general concept is it is some words that we just don't want to include. They are words that you don't want to include into your analysis for X or Y reason. Most of these words are meaningless or just don't have a lot of meaning carrying to them or are awfully common. Combination of all of those 3 factors, we just don't want them and we can exclude them. Why? For more advanced stuff, especially if you're looking into the LLM stuff, large language models, transformers, etc., complexity increases really quickly with the number of words on the training model. The more words you add, the not exponentially, but it just starts adding more complexity you will have. It is just better to get rid of those words and use as few words as you can while maintaining the meaning. So that is a trick here. We are removing those words, and yes, it does not sound too English to us. And you will notice that something is missing, but you can get the meaning, and you will see that in a second. We're going to take the stop words that the NLTK has for English. Again, if we were making this from scratch, we will need to make our own list of stop words. That's perfectly possible if you want to. You can see here how stop words is at set, and it has a size of 179. Dal, yourself, was, with, only, etc., etc., etc. A lot of very common words in English that you will have here and there. And then we will create a new list that is going to contain the words that we want to. After we do that, we're going to take advantage of for loops. We have already revisited for loops a couple of times before. You are taking something that you can iterate in, what in this case, and you're saying for W in Word, if W in any case is not in stop words included here. There is an else condition here that is implicit saying else don't do anything. You're going to skip that to the next word, but that is implicit. Now, after that, we can print the field list. Now, you can read that and it may sound a little bit too gibberish to you, but string help us understanding natural language processing. You can see, you can get at least part of the meaning, and honestly, you may actually know somebody that writes that way. That is the meaning of stop words. You are taking out stuff that you don't need and keeping the stuff that you need. Because complexity, how those processing the data, etc. Again, if you want to go more into the theory about it, there is a lot into it, and there is a lot of different packages of stop words. Every language has their own stop words. A lot of this is exclusive to English. Even in other languages, they are more limited because a lot of these capabilities were developed for English. And you will just have a harder time, or you will need to create your own lists. Just keep that in mind too. If you are trying to work with another language, Python will take it, but either you may need to add more stuff to your stop words to make sure that you're filtering all those common words into language that they just don't carry a lot of meaning. Now, the next concept is part of speech. It deals with the role that the words play in sentences, and we will take that in the POS stack. You can see here that you have these very funny codes, and it says help us understanding all the filter words that we had. Now, what these codes mean, you know how programmers are. We are lazy a lot of times. We just want to make something handy. You have this help that helps you to get the tags. You can see here, for example, you have verbs, past tense, base form, present tense, etc. And you have a very long list of codes on this. So NNP for computer, it will be a noun. It is not any kind of noun. It's a proper noun and it's a singular. A lot of this will probably sound like your elementary school classes. That's not an accident. It is based on linguistics and grammar of the English language, and more generally, linguistics. Natural language processing, as one of my professors will have defined it, is an intersection between computer science and linguistics. That is a lot of what's going into this. We are trying to make the computer understand what language means, and for that, we need the stuff that you learned back in elementary or middle school. What is past tense? What is future tense? How does it relate to this kind of meaning? Am I saying that something happened to me? Is it happening to me? Will it happen to me in the future? Is there a chance? Would it have happened given these conditions? You may do this all the time mentally without realizing. It's just a second nature to you. But computers cannot understand this language. Therefore, they need to take that logic, that association through it. Now, something else for you to keep into account, if you want an actual bigger deal or a side project, maybe, if you want to do something like that, you could try to join this POS tag set into the actual data set. So you could have this exactly as you have here, and then either add a third side here in this tuple and say this is what it means, or replace the code. You will need to basically do a join between the codes and this and a lookup, and then replace those. There is other way you could do it. I'm giving an idea. I may explore it in a future video if you will be interested on that. That is just a shameless plug. But if you want to challenge yourself, just giving yourself a personal project or side project, or you just want to brush up your skills on Python, give it a chance, see how it goes. It will be just good practice for you, especially if you're struggling to try to get that personal project going on. This is a very good example. You have a data frame, not the data frame in this case, it's actually a list of tuples, but you get my point. You have data and you need another field from somewhere else. How do you bring that field? It has a lot of implications. And if you're able to do this on Python, it is easier to do in SQL and in other programming languages as well. Again, I'm just throwing up that there. If you want to keep that, do it. I may add it as a 1.5 episode to this because I don't think that will be a part 2, but it will be useful for you to brush up your skills. Now, we also want to build something called a frequency distribution. This is something very straightforward. If you actually take the frequencies, it is going to tell you how many times a word appears in the text. I just took our filtered list and just said, hey, just return me everything and tell me how many times it appears there. Now, the good thing about NLTK is that it has a function that, yes, you could have built it, there's a lot of ways that you could do it, aggregations, pandas has options, but if it's there, it's a function, it's in the package you imported. It is just easier. And then it also has plot. You can plot this very easily. And then we can go to plots and you can see that help and language are the two words with 3 followed by this column. And then the other words were mentioned way less than that. Now, this will change because we can also use all data. Use all words in this case. I'm going to do exactly the same I did here. I'm going to copy this. And I'm just going to call it frequency2 plot. And then instead of doing it in field list as instead of doing it in field list as I did it before, I'm just going to do it in word instead. Just so you can see how it varies and why we actually use all of these top words. I mean, there you go. You can see there is a lot more words than before, but out of them are will, help, language. We need these two, but that doesn't tell us a lot. All this is, those are just points that don't help us getting the meaning of text. They are just there because they are common in English. That's pretty much it. There is not really a lot of mystery. People use these words a lot. You may hear of the common trope of filler words. These stop words will also include filler words because they don't have a lot of meaning. We don't really care about the meaning behind them because they don't have meaning. We are better off getting out all those words and keeping what we actually want to keep. Our last concept in this video will be sentiment. There is a lot of theory behind it again. You can read in your own time about it. And I will make a whole series about natural language processing because you can cover a lot in this topic actually. But for the context of this video, you just need to understand that it's a general thermometer of how we feel about that sentence. Do we feel that the person that submitted the sentence felt good, bad, somewhere in between, whether mostly neutral? And again, NLTK has a very handy sentiment analyzer. You will see from working in other data analytics computing videos that the syntax is very similar to our machine learning models. You are taking this, it looks very similar actually to scikit-learn. You're taking this package and then you're just assigning to create a variable with that package. And after that, we are just going to use that to get these sent scores. You can see there is almost no negative. Actually, I did not intend it to be negative at all, but you can just read it again to see if you see any negative in that word, in that sentence. Mostly neutral and a little bit positive. And the compound is 86%, mostly positive because this goes from 0 to -0. And you can see that it's mostly because it's positive and neutral, mostly in the neutral side. If it was very negative, you will see this going a little bit less on the compound side too. But again, natural language processing is a very powerful tool. It is the basis of a lot of the large language models. You may have heard about n-grams, more advanced ways of analyzing language and how human language can be understood by computers. It relates to a lot of theory too on how Google is able to get search engines, for example. ChatGPT uses a very, very, very complex deep learning model, but at the end of the day, it needs to understand what people are saying. So the transformer architecture behind it is the main deal on the GPT side of it. There is a lot of academic papers there that you can spend days and days reading. I would just say that if you want a general introduction, this is more than enough to get the grasp of what's happening here. Computers need help putting some guardrails, if you wish, on language and being able to use this language in different ways and then build your fancy stuff like frequency tables, n-grams, and eventually chatbots. But you need to start from somewhere. And this is a good introduction. With that, I hope that you found this interesting. Please let me know if you think I skipped anything, if you will find useful to have a second part to this elaborating these concepts. I most likely will do at least another part on this. And again, any feedback and any support is appreciated. Thank you. Have a good day.